Assalamu alaikum and good day to the Honorable Session Chair and respected audience. I am Farhana Haq, PhD student from Green Networking Research Group, Department of Computer Science and Engineering, University of Dhaka. Here I present the paper titled Quality of Service Award Order Allocation for Interregional Online Food Delivery Systems, authored by me, Farhana Haq, Nahar Sultan and MD Abdul Razzaq. This paper is accepted in ICACT 2023. In this paper, we design an order allocation strategy for online food delivery system considering the delivery region. Here is the outline of my presentation. At first, I want to introduce my research area. My research area, online food delivery system, is a specialized application of mobile crowdsourcing where the online customers can place food orders to their desired restaurants through a delivery platform. Then the platform assigns the workers to pick the order from the restaurants and deliver to the customer's location. In recent times, these services become popular because of the hectic pace of modern life. Many people prefer to have their food delivered at their doorsteps. So the global online food delivery market size was valued at USD 189.70 billion in 2021 is now expected to expand as a compound annual growth of 10.8% from the year 2022 to year 2028. The growing trend toward the online food delivery, mobile applications, and the growth in the food industry is the emerging economies are the factors that contributing to the growth of this market. And this rising popularity of the online food delivery system has reached at Bangladesh, and it offers a new dose of convenience to the customers of Bangladesh. But yet, to be a sustainable technology, the system requires extensive research to address the complex challenges. As compared to the other on-demand services, food delivery is one that receives a massive volume of order, and as the products are highly perishable, the system needs a strict deadline to maintain. And to cope with today's highly cognizant customers' expectation, the system needs a speedy and reliable service also. As the competitive market of online food delivery sector escalates, the platform have to develop the numerous approaches to address the various requirements of customers and improve the delivery efficiency. As we know, the traditional platform restricts to serve the order within a specified delivery region. So it is a great concept to provide the customers more choices for placing their orders with expanding the delivery region, because a larger delivery range means more choices for customer, which can increase the number of customers and make the platform and restaurants to get more profit. In reality, sometimes the customers may prefer to place orders from the other region, which is not his or her local region. And to meet these customers' requirements, the restaurants requires the own delivery service rather than the online food delivery platforms to transport these orders. So it is important for online food delivery platforms to do research on interregional food delivery facility to enhance the quality of experience of its customer. So our research question is how to provide the customers the flexibility of expanding the delivery region to increase the order diversity and how to allocate the interregional orders to minimize the service time and enhance the quality of service of the system. To do research with these questions, we went through many related works, and here I present two of them. The first one is the Food Net, published in IEEE Transaction in 2019. And in this paper, the Liu et al. Design an optimal taxi route for long distance delivery and schedules the food delivery orders. And their proposed system improve the delivery efficiency by leveraging the existing resource of taxi. But their work is limited only to taxi route, and they optimize the routes in the traditional delivery mode. That is, they did not consider the interregional concept. And in this work, the Lee et al. Proposed an order splitting strategy based on transfer stations for long distance food delivery in their work titled Meal Delivery Routing Optimization with Order Allocation Strategy based on transfer stations for instant logistic services. In 2022, they designed a research framework consisting of order combination, splitting, and meal delivery routing. They proposed an order splitting strategy, but they did not consider the vehicle capacity or workers load, and also their proposed systems is has the lack of synchronizing the workers schedule, which hampers to the maintenance of quality of food order. So in this system, we develop an order allocation strategy, Kushal FG, based on the transfer vehicle for the interregional long distance food delivery, which can broaden the scope of online food delivery and satisfy the different requirement of customers. And to achieve this, we formulate an optimization framework that assigns an interregional order to a transfer vehicle that enhances the number of orders by expanding the delivery region and minimizes the service time. We evaluate the performance of our proposed Kushal FD in terms of the average number of orders and average service time. We consider an online food delivery system. In our proposed system consists of food delivery platform, transfer vehicle, restaurant, delivery rider, and customer. The platform centrally coordinates the interactions among the other entities, and they are connected to the platform through the registration process. A customer can place food order from a local restaurant, which is considered as intra-region order, or place order from a distant restaurant beyond his or her region, which is considered as inter-region order. In case of inter-region delivery, the dedicated vehicles are used for transferring orders to a workers of delivery region at a mutual meeting point for delivering the orders to the respective customer's location. We assume a transfer vehicle is always available in the pool. If not, the customers whose orders are associated with this vehicle should be notified. This transfer vehicle based order allocation strategy is illustrated in this figure. The platform, restaurants, and workers get their appropriate portion of revenue when an order is completed successfully. For intra-region orders, the platform generates an initial set of orders based on the region of delivery. Then, after being allocated by the platform, the transfer vehicle collects orders from the restaurants and delivers them to the corresponding workers at the meeting point within the estimated delivery time. Manhattan distance is calculated to estimate the position of meeting point of transferred vehicle and workers considering the characteristics of the complicated urban road network traffic. In the proposed system is assumed to have several meeting points to ensure the faster delivery. And in this work, we emphasize on the allocation of inter-region orders. Thus, we consider the special information of only inter-region orders and the transfer vehicles. As we know, service time is an important and critical point for online delivery system because it has a significant impact on the performance of the system. And to address this issue, we calculate the total service time of a transfer vehicle to deliver an order from one region to another. In equation 1, we calculate an estimated individual order pickup time by considering the traveling time that is required to travel from the location of transfer vehicle to the pickup point location of order and the food processing time. And and the platform forecasts the duration of travel time using Google Maps API, which depends heavily on the distance covered by the road network, and estimate the order processing time of a certain order from the past historical data. A set of orders generated to pick the orders from a respective restaurant. Accordingly, this individual order pickup time. And following the sequences, the designated transfer vehicle collects the orders from the restaurants for delivering to the workers at meeting point. And so the total pickup time of the transfer vehicle for interregional orders is calculated as in equation 2, where we consider the maximum time of the individual order pickup time of an order and we select the meeting point of a specific regional set of orders based on the shortest distance between the locations of meeting point and the current locations of transfer vehicle. And finally, the total service time of transfer vehicle calculation is the combinations of the total pickup period of a transfer vehicle and the traveling time to reach at the meeting point. And our system aims to assign a transfer vehicle a set of interregional orders in a way that reduces the total service time of the transferring the orders from one region to another. So our objective function is to minimize the total service time of the assigned transfer vehicles of each order with subject to these constraints. The constraint 6 is the order deadline constraint that ensures that the estimated service time of a vehicle to arrive at the meeting point for an interregion order must not exceed the maximum delay tolerance time. The constraint 7 is the vehicle capacity constraint that guarantees that the total assigned orders to a vehicle must not exceed the carrying capacity of the transfer vehicle, and the constraint 8 confirms that the order allocation will be unique to a vehicle. It implicates that a single order will be allocated to a single transfer vehicle. After that, we evaluate the performance of our system the simulation and the experimental evaluations are carried out in Python on a real-world dataset, as in our reference work, and the dataset contains the real-world historic experience of food delivery services, and we consider an area of 15,000 by 15,000 meter square where the location of restaurants, order and workers are randomly distributed, and the orders, vehicles and restaurants information are extracted from each instance of the dataset. The number of restaurants are kept in 50 and the number of orders are varied from 100 to 500 and the number of vehicles are varied from 5 to 30, and 20% of the total orders are selected at interregional order based on the fact of the distance between the restaurant node and customer node. And all simulation experiments were conducted on a PC with an Intel Core i7 processor and 16 GB memory running Ubuntu 20.04. We consider these two metrics to evaluate the performance of our system. The average service time is the average interval between the reception of an order and its delivery to a meeting point by transfer vehicles, and the lower value represents the better performance. And the service delivery improvement metric is a percentage of number of orders that are increased due to the interregional orders that are placed on the platform, and the higher value indicates the better performance. And here the graph shows the performance of our proposed Kushal FD in compared with the another state of art work named MIP MD RP. From the graph, we can see that while we varying the number of orders, our proposed Kushal FD outperforms in terms of average service time and in terms of service delivery improvement. And when we vary the number of vehicles, here we can also see that our proposed Kushal FD is outperforms than the MIP MDRP in terms of the average service time and service delivery metrics, because our proposed Kushal FD consider the inter-regional order and consider the mutual meeting point and a transfer vehicle. So this accelerates the total delivery time. So in conclusion, we can see that our proposed Kushal FD system expands the delivery region, increase the number of orders and minimizes the service time, and it get the improvements over the other state of artworks in terms of the average service time and the percentage of service delivery deadline. In next research plan, we have to assign the workers for interregional delivery orders by taking the consideration of the all aspects of interregional delivery, and we also want to apply the learning algorithm to estimate the total service time to achieve the more accurate result. Thank you all. This is from my side for today.